The relationship between the derivation sheet and the two diagrams is one of foundational theory, educational storytelling, and procedural logic. The derivation sheet acts as the primary knowledge base. The state diagram serves as an evolutionary roadmap for the interactive demonstrations, and the sequence diagram provides the step-by-step workflow of the analysis. The foundational narrative, derivation sheet. The derivation sheet provides the core concepts of the vortex paradox. It establishes the central conflict, a force field that appears calm and free of rotation at every individual point along a traveler's journey, yet produces a significant, measurable score once a full circle is completed. It identifies that this surprising result is entirely dependent on whether the traveler chooses a path that traps a central forbidden point, known as a singularity. The educational journey, state diagram. The state diagram translates the derivation's abstract conclusions into a structured series of visual demonstrations. Its relationship to the source text is one of organization and layering. Path selection. It mirrors the branching logic of the derivation, where the user must decide if their journey orbits the center or avoids it. Layered complexity. It shows how the simple act of tracing a path evolves into a more detailed explanation by adding tools like lap counters and real-time graphs to prove why the final results differ. Topological comparison. It culminates in a side-by-side view that visualizes the topology concept described in the text, showing how the shape of the loop dictates the outcome. The analytical workflow, sequence diagram. The sequence diagram focuses on the logical interactions required to reach the derivation's final conclusion. It maps the relationship between the mathematical rules and the visual proof. Step-by-step logic. It outlines the progression from identifying the field's basic local properties to verifying its global behavior through computer-generated models. Verification. It illustrates how the solver uses a visualizer to confirm the winding number theory, showing that the final result is a direct consequence of how many times the path orbits the hidden center. Integration. It captures how different scenarios, enclosing versus non-enclosing, are processed to validate that some paths cancel their own progress while others do not. In summary, the derivation sheet provides the reasoning, the state diagram manages the demonstration pipeline, and the sequence diagram tracks the logical execution.